Hi and good day everybody. So I want you all to look back on the topic of non-homogeneous second order ordinary differential equation before, where we can solve our second order ODE by using undetermined coefficient method. Okay, so this one is for undetermined coefficient method. Okay, for undetermined coefficient method, where if you can remember, to find the solution of y, we need to find what is our yc and yp. Okay, where yc is solving the second order ordinary differential equation homogeneous part. Okay, and we need to find what is yp. Okay, previously for the case involving polynomial and also exponential for our fx, okay, when our fx is involving a polynomial and exponential function, I teach you to find yp by comparing our fx here by c x to the power of n exponent r to the power of x. Okay, so you can have a value of n, a value of r, and a value of s. Therefore, you can rewrite your yp in terms of x to the power of s an xn plus a naught erx. Okay, but this is only applicable for the fx which involve polynomial and also exponent. But when we have fx involving a trigonometric function, we no longer can use this method. So today I will teach you how to solve the non-homogeneous second order ODE by using undetermined coefficient if it's involved a trigonometric function. Okay, so let's see it together. Okay, let's see one equation involving a polynomial with trigonometric function here. Okay, let's see one simple equation. When you have a second order ODE d square y dx square plus 4 dy dx equal to 3 cos 2x. Okay, so now you have your second order ordinary differential equation, which is a non-homogeneous, and you need to solve it by using undetermined coefficient. Okay, so to solve this type of equation by using undetermined coefficient method, you need to find what is yc and yp. Okay, to find yc, let us solve this part first. We make it as homogeneous second order DE, so it will be d square y dx square plus 4 dy over dx equal to 0 because we want it to be homogeneous. Then we turn it to be characteristic equation. So we have lambda square plus 4 lambda equal to 0. So our A is equal to 1, our B is equal to 4, and our C is equal to 0. Therefore, B square minus 4AC is equal to 4 square minus 4 times 1 times 0. So you will have 16 here, where 16 is greater than 0. Means that you will have a case number 1 where you will have two distinct real root. Okay, so the value of lambda that you will get if you factorize it manually or by using calculator is equal to 0, and your lambda 2 is equal to 4, negative 4. Okay, your lambda 2 is equal to negative 4. Okay, so now you have your yc equal to a exponent 0t, a exponent 0x plus b exponent negative 4x. So exponent 0 is equal to 1, therefore your yc is equal to a plus b exponent negative 4x. Okay, now you want to find what is your YP, but for this case your YP cannot use the previous technique that we used in polynomial and exponential case. So how to find YP for the trigonometric function? The first thing you need to do is you need to list down the derivative family of your fx here. So this one is your fx. Okay, we ignore first the constant, so your fx is cos 2x. So we list down the family of derivative, means that you have fx here, differentiate cos 2x, you will get sine 2x, right? Okay, then differentiate sine, you will get cos 2x. Okay, you will get negative cos 2x actually, but we just ignore the constant negative one, so we just list down the cos 2x. Then we differentiate again cos 2x, you will again get the sine 2x, and differentiate sine 2x, you will get the cos 2x. So the family derivative is circulate in these two function. Okay, so we call this one as the derivative family for our fx. Okay, now, so from this derivative family, what you need to do is you just list down your yp as c. C is a constant of the first one, sine 2x, plus d cos 2x. Okay, then you compare your family of derivative here with the solution in YC here. If you see your general solution YC, will have a solution Y1 as 1 and Y2 as exponent negative 4x. Okay, and this one is different, where you will have no connection between these two solutions. Therefore we call this function as a linearly independent. Okay, therefore your yp will be in the form of c sine 2x plus d cos 2x. So you will continue do the same thing as before, where you need to find what is your yp prime. So your yp prime will be differentiate sine, you will got cos, so you will have 2c cos 2x plus 2d minus 2d sine 2x. Okay, then you find your yp double prime as before, so you will get negative 4c sine 2x minus 4d cos 2x. Okay, so then we will substitute our yp double prime, yp prime and yp inside the equation here. So you have yp double prime first, so let's write it here. Yp double prime is negative 4c sine 2x minus 4d cos 2x. Okay, plus with 4 single prime, so plus with 4 times with y single prime here, 2c cos 2x minus 2d sine 2x equal to your fx is 3 cos 2x. Okay, so we write down 3 cos 2x. Okay, now we simplify or we expand this equation. What we will get is you just collect the same term here. So we have cos 2x here and cos 2x here, so we collect the same term. Okay, so what you will get here, let's write cos 2x outside the bracket. So in the bracket you will have negative 4d and for this one, don't forget to times 2c with 4 first. So you will have positive 8c in the bracket. Okay, same goes to the sine 2x. You put it outside the bracket. And if you see here, you have negative 4c and 4 times with negative 2d. Okay, so what you will have in the bracket is negative 4c minus 8d equal to 3 cos 2x. So now you can compare right hand side and left hand side, where right hand side we have cos 2x, here we cos 2x. Therefore the first equation that we have here is negative 4d plus 8c is equal to 3. Okay, and you cannot see any sign to x in the right hand side, therefore it is 0. Okay, it is equal to 0. So our second equation that we get here is negative 4c minus 8d is equal to 0. I rearrange this equation. I put d in front and c at the back. So I will get negative 8d minus 4c is equal to 0 for this term. Okay, because in left hand side we have the sign to x term, but in the right hand side we don't have sign. Therefore it's meaning that we have 0 sign to x, so we can compare this one with 0. Okay, so now we have two simultaneous equation that we can solve it simultaneously. Okay, let's solve this one either by using calculator or manually. You will get your c equal to 3. Your c is equal to 3 over 10, and you will get your d is equal to negative 3 over 20. Okay, so you can solve this by using calculator. So when you get this value of c and d, you can substitute it back in your yp here. Okay, here is your yp, so just substitute back your value of c and d in your yp. Therefore you will have your yp as 3 over 10 sine 2x minus 3 over 20 cos 2x. So this one is your yp. So now we can find the solution to our differential equation y, where y is equal to yc plus yp. So what we will have is our yc is a plus b exponent negative 4x, plus with our yp all here is 3 over 10 sine 2x minus 3 over 20 cos 2x. So this is the solution to our second order differential equation.